Ladies and gentlemen, so today what we're going to be doing is we're going to be talking about solution molarity. So molarity is going to be a little bit different than the molar mass. We're still going to be using moles, which is that funky unit that's that 6.022 times 10 to the 23rd particles or atoms of something. So we're still talking about moles, but this time we're talking about a solution. So we're talking about putting some solid or another liquid into a solution, usually a solid into a solution, and then trying to make it dissolve, trying to make it become a mixture. So in order to do that, we need to know how to figure out a couple things. We have to make sure that the solid is soluble in the water, usually what we're using. We have to make sure it's soluble in water, and we have to make sure that we can figure out how much of that solid we need to use. So how many grams we use of this solid. So molarity is going to be its own special unit. And so if we look at our worksheet for today, molarity is really just the moles of our solute, the thing we're dissolving, divided by the volume or the amount of liters of solution we have. So if we look, molarity is really a concentration. It's a concentration of a solution, and it's the number of moles of the solute. So this is our solid usually. The solute, if you remember, is the thing that we're trying to do to dissolve. And it's dissolved in 1 liter of solution. So it's moles per liter. So it says here molarity equals moles of solute divided by liters of solution. We usually write this equation, moles equals, or molarity equals moles divided by liters. And then we can also think back, way back to the beginning of the semester, again, talking about density. If you remember, we had that density triangle. I don't know if you guys remember that one or not, but we had a density triangle. It was a triangle. And on that triangle, we broke it into 3 sections. And then we have our different sections, our different units. For us, this would be for molarity, it's going to be moles up here, molarity down here, and liters down here. Remember how this is a different way or just an extra way we can solve for molarity. If we have moles and liters, we cover, and we're looking for molarity, we cover up the molarity with our finger, and then we take moles divided by liters. If we have moles and molarity and we're looking for the amount of liters, we can cover up the liters with our finger, and we take moles divided by molarity to find liters. If we have the number, if we're looking for the number of moles, we can cover it up with our finger, and we can multiply our molarity times liters to get the number of moles. Maybe you guys remember that from density, maybe you don't. That's just another way of remembering how to solve for these things. We are going to go through some information together though. So it says calculating the molarity is the easy part. It's simply just divide the number of moles by the liters. If the problem gives you grams though, that's when it gets a little bit trickier. When you start with grams of something instead of moles of something, you first need to find that molar mass, and then you need to convert the grams to the number of moles. Also, you have to remember that the units for molarity need to have liters. So if you are given milliliters, you have to remember that you have to convert milliliters to liters, which means you would have to convert by dividing by 1,000 or moving the decimal place 3 times to the left. So if we look at this example, it says a saline solution contains 0.90 grams of sodium chloride in a 100 milliliter solution. What is the molarity? We first have to find the molar mass, and then you are going to take that molar mass and divide it in here. So this 58 point is our molar mass. MM for molar mass. Oh, and we've calculated the number of moles. And then once we calculate the number of moles and we have our milliliters, we've converted to liters, we can take our moles divided by liters to get the molarity. So let's look at the problems below. It says calculate the molarity for each of the following solutions, and we need to make sure we check if the compounds are soluble. So if we are checking to make sure our compounds are soluble, where will we look? Where are we going to look to see if the compounds are soluble?
So solubility rules chart.
Perfect. Our solubility chart or our solubility rules chart to look to see if our compounds are soluble. And it will tell you soluble, insoluble, slightly soluble for almost all the solutions or compounds we're talking about. If we look for this first one, it says 1 mole of potassium chloride in 750 milliliters of solution. Before we do anything else, we always check solubility. If our substance like potassium chloride, if that is not soluble in water or in solution, we don't have to do the problem, which just makes our lives a lot easier. So always check solubility first. And is potassium chloride soluble?
Yes.
All right, so potassium chloride is soluble, which means we have to continue doing the problem. And so if we're going through this, one way we could do it is identifying the three variables we are looking for. So we have moles and we have milliliters. Are those two the correct things to solve for molarity? Those two the things we need to solve for molarity?
Isn't it supposed to be liters instead of milli?
Exactly. It needs to be liters. So the moles are right. We're good here. But this needs to be liters, not milliliters. So we need to do our conversion. And so if we were setting up our conversion with our lattice structure, our railroad tracks, we always put our given right here, which means 750 milliliters. We need our conversion factor right here. And our conversion factor is the two sides or the equation that we use to go from one unit to another. So can you tell me how many milliliters are in how many liters? How many milliliters equal how many liters?
1,000.
1,000 milliliters equals 1 liter. So now we need to take this conversion factor and we need to put it into our railroad tracks, our lattice structure. Do I put my 1,000 milliliters on the top or my 1,000 milliliters on the bottom?
Bottom.
On the bottom, because we want those units of milliliters to cancel. That means the 1 liter goes on top. Those milliliters cancel, and we do 750 times 1 divided by 1,000. And how many liters is that?
$7.5.
Everybody agree?
Never mind. It's 0.7.
It's 0.75.
There we go. 0.75 liters. Perfect. All right. So now that we have liters and we have moles, we can calculate our molarity. So molarity equals the moles divided by the liters, which means we can replace moles and liters. So molarity equals 1.0 moles divided by 0.75 liters. And we solve for our molarity to be what value? Anybody get a value?
One 1.33.
1.33 molarity. Then we just have to check our significant figures. How many significant figures should we have for this problem? Now, problem number 1, how many significant figures?
Three.
3. Let's check again. So we have how many for our moles?
2.
And how many for our milliliters?
2.
So how many should we have in our answer?
2.
2. All right, so let's change that to 2 significant figures, and we are done. Any questions? All right. I'm going to leave number 2 for you guys, but I want to do number 3 together as well, just because it starts with grams now. So we're starting with grams. So if we're looking at number 3, we are looking at 400 grams of copper sulfate in 4 liters of solution. So what's the first thing we're going to do?
Check its solubility.
Check its solubility. Is copper sulfate or copper 2 sulfate, is it soluble in water?
Yeah.
It is soluble. Perfect. So we have to continue because it's soluble in water. So now let's check for our molarity. We know we need moles and we need liters. Do we have moles and liters for this problem?
No.
No. Do we have either of them?
There's liters.
There's liters, so we know this is good, but we have to do what with these grams over here? Can we get grams to moles?
No,
It's not possible?
you have to turn it to liters.
We already have liters, so now we're just trying to get our moles. So is it possible to go from grams to moles?
Yes.
All right, well, how do we go from grams to moles? What do we have?
Check the molar mass of the compound.
Molar mass. All right, so it's a compound, so we have to find the molar mass of quite a few things. So we'll find the molar mass by looking at our periodic table. We need to find the molar mass of copper, of sulfur, and of oxygen. Can anybody find me any of those values?
For oxygen, it's 15.999.
Awesome.
Sulfur is 32.06.
Awesome.
Copper is
Multiply oxygen times 4.
We have to multiply oxygen times 4. And what was copper?
63.546.
Awesome. So we have one copper, which is why we just had that 63.546. We have one sulfur, which is why we have the 32.06. And we have 4 oxygens. That's why we have the 15.999 times 4, because there's 4 of them in our compound. So now we have to take that and add all of our values together to get our total molar mass. Who can tell me the total molar mass?
Oh, 159.602.
All right, so 159.602. And then our units for this one, this is the number of grams of copper sulfate that is equal to 1 mole of copper sulfate. So that's the number of grams that equals 1 mole of copper sulfate. So can we use that to convert from grams of copper to moles of copper sulfate? Can we convert our 400 grams of copper sulfate to moles
Yeah.
of copper sulfate? Awesome. So let's set up our lattice structure, that railroad track. In the top left, we always put our given. In this case, the 400 grams of copper sulfate. In our next column, we put our conversion factor. And in this case, our conversion factor is our molar mass. Where do I put the 159.602 grams of copper sulfate? Do I put it on top or on the bottom?
The bottom.
On the bottom, perfect, because I need my grams of copper sulfate to cancel out, to go away. So my units of copper sulfate can cancel out right here, which means my units I'd be left with are on top, the moles of copper sulfate, which is what we're looking for. So now we take that number of 400 times 1 divided by 159.602. And when we do that math, what do we get for our value of moles of copper sulfate?
$2.506.
All right, 2.506 moles of copper to sulfate. And then we just have to check our significant figures to keep them constant. How many significant figures do I need to use for this part of the problem?
3.
3 significant figures because 400 with that decimal point tells us those zeros count, which tells us 3. So we're going to erase that 0.6 and we're going to replace it with the 5.1. So 2.51 moles of copper 2 sulfate. Now that we have the number of moles, can we calculate the molarity of this solution? The concentration.
Yes.
All right, so we have our molarity calculation is equal to the moles divided by the liters. We're going to take that 2.52 moles or 2.51 moles divided by the 4.00 liters. And what do we get for our molarity when we do that division?
Zero 0.6275.
All right, and if we put that in significant figures, how many significant figures do we need?
3.
3. So let's change that to 628. And then put the units of molarity with a capital M, and we are done. Not too bad, right? Hopefully. All right, so that was the last problem we were going to go through together. I do want to talk about one more thing or two more things. So the problem 2 and problem 4, you're calculating molarity just like before. In problem number 3, you are going to be solving for the other 2 parts. Most of the time you're solving for the number of moles. Some of the time you are going to be solving for the number of liters for that solution. Make sure you're always checking for your solubility, because if it's not soluble, you don't have to do the problem. You just have to state not soluble or insoluble. The last thing I wanted to look at was this last page, page 3, which talks about making dilutions. So chemists often often use more concentrated solutions, so higher molarity concentrations, to make some more diluted solutions, which just means there's less moles or there's more solution, more liquid in the solution. It just changes that concentration to a smaller number. This is especially useful when we use things like acids, because the higher the concentration, the more dangerous they are. We have something called hydrochloric acid, which we use a lot in chemistry class. If you take it straight from the giant jug that we pull it out of, it is a concentration of 12. If you poured that on your skin, it is going to eat through your skin, go straight to the bone. It is going to hurt a lot. The concentration that we usually use in class is no higher than 1, because it is just so dangerous to use with a higher concentration. So the higher the concentration usually means there's a more dangerous solution. So we want to keep them at lower concentrations to make them safer for us to use. When we're doing these dilutions, it's actually a very simple calculation. You take the molarity of and the volume, and you multiply them together on one side, and you take the molarity and the volume and multiply them together on the other side until you have them equal one another. So if you're missing one of these variables, let's look at this example. It says, how would you prepare 100 milliliters of this 0.4 molar solution of magnesium sulfate from a solution of 2 molar magnesium sulfate? So we know that we started with 2 molar magnesium sulfate. So that's our M1. We're trying to figure out our V1, our V2, our volume that we ended with was 100 milliliters. And our final concentration was 0.4 molar. So all you do is you find and isolate the variable you are looking for. So you isolate that V1 by dividing 2 molar to the other side, and you find your volume. This one is especially easy because you don't have to do conversions unless your volume units don't match up. So if you're in milliliters to start, you do not need to get to liters because your answer can just be in milliliters as well. So for this one, you just have to make sure both your volumes are in the same units, but it does not matter if it's milliliters or liters. Just make sure they're both the same. Do you guys have questions on what you should be doing for class today? All right, then if you guys have no questions, you guys are good to go and have a wonderful weekend. I'll see you guys next